Good. So yesterday there was a mistake in the previous lesson 73. Our answer, our example 2 had an answer of sin theta equals 0,899. And then when we worked it out, this was not our answer, this is the correct answer. Please correct that for me. So it's shift sin to get to the angle. When I have the ratio to get to the angle, it's shift sin. Just make sure that you correct that mistake. The question for homework was to find the unknown, to find the x, which is a side. So you now know I'm solving triangles. So can I use grade 10? Normal sin, cos, and tan. Why can I not use that? I don't have a right angled triangle. So I cannot use that. Do I have pairs? Yes. Because that's the rule for the sin rule. Sin rule says I've got to have pairs. Do I have pairs? Yes. I've got one pair. The cube pair if you really wanted to, the angle and the side. This is the one I'm looking for, so I needed that angle, and I don't have it. So it's not a major problem if you didn't see it, though it was a major problem. To find that angle, it was 53. So then please tell me that R is 53. And do you need to say sum of the angles of a triangle is 180? No, you don't have to because you're not in geometry. If you say it, it's fine. If you don't say it, it's also fine because you're in geometry. Now I can go for the sin rule. So when I want to use the sin rule, first write down the sin rule. So whether it's the angle or the side that you're looking for, it doesn't matter. I need the sin rule to be written. Safety. Then I'm looking for x, which is actually a side. Now I've written the angles at the top and the sides at the bottom. Doesn't matter. I just want to see the rule, whether it's at the top or the bottom. I'm going to put the x at the top because that's the way I taught you. It's just good ways of doing sums. So I'm going to put the x at the top, which is a side, over the sin of 53. Then the other side that I'm going to use is 21 over the sin of 95. Please be careful that you don't write 95 over the sin of 21. This makes sense. Sin of an angle makes sense. You can't have sin of 21. 21 is a side. Yes, ma'am. And both have to look the same. Side at the top, angle at the top, angle at the top. And you can manipulate. So if I started this sum off with sin 53 at the top and x at the bottom, same thing on that side, it's fine. You're just going to manipulate to get to your answer, and that's fine. You can manipulate well now in equations. So the answer for x, please? 16,84. 16,84. 84 what? There's nothing. So if you write units, I like it, but it's not worth a mark. And nothing is also fine. But if there was meters, I'd like meters. And if you lose the meters, it's also not the end of the world. Right, number 2. The question was to find theta. And the question was there for a reason. This one I found a side, now I'm going to find an angle. But the first thing that you look at is I cannot use grade 10 because there's no 90-degree angle. Maybe it worked out to 90 degrees eventually. It's not to say, but I cannot use grade 10 work here. I have pairs, do I? Yes. Straightforward, yes. I have a pair, the 40 and the 46. And this is a half a pair. That's the way you always look for your sin rule. The pairs are there. So I'm again writing the sin rule. Right.
Yes.
No. Okay. And I'm writing the angles at the top. I should, but I didn't. It's okay. But when I write it now, I'm going to write sin theta at the top, the question, over 70, and then it will be the side of the angle, 40 over 46. Are you seeing I'm trying to confuse you a little bit? You're just going to know that the angles and the sides have to correlate with each other. So that my answer for sin theta will be 0,978. Okay, I don't need to have a lot, but you just write dot dot and don't round it off in your calculator. And then you shift sin. If you shift sin, you're going to get
78.
Okay, 0 degrees. Now, I wanted you to go do this sum, but actually there was more than one answer. So now today I'm getting to that. Once you now first of all know the sin rule, There is such a thing as an ambiguous case. What does ambiguous mean? Big word.
Not sure.
There are two possibilities. In other words, that's the word, the meaning of the word. This only happens in a case where I give you two sides and an angle. And the angle that's given is opposite to the smaller side. Now this is going to sound very confusing, but let me just let you at peace at first. You will not get caught out with the sum. My question will be in the sum. Find the values of theta. That is going to give it away. Or I could have asked you, find me theta and theta is an obtuse angle. Or find me theta and theta is an acute angle. It doesn't make any sense to you at the moment. I will help you to understand or to recognize that there's got to be more than one way of doing it. And if you got here, you would have lost 1 mark if you did exactly what you were doing over here, because there is another possibility. For the reason that if I give you two sides and an angle opposite the shorter one of those two sides. So it is definitely sin rule, so I've got pairs. But the one opposite to the angle is the shorter one of the two. So in other words, here's my angle, the two sides, but the side that is shorter is opposite to the angle. What it means then, and guys, you don't have to have EGD and all sorts of techniques here, but what it means then, if you actually want to sketch this thing, and you have to have 70 over here, there's my E, and it's exactly 70. There's no way it can be anything else, it must be 70, right? This angle here must be 40, so I look at my protractor, my compasses and everything, and I've got exactly 40 degrees. But how long is this line? We don't know, we've still got to calculate that. How big is this angle? I also don't know. How big is this angle? I also don't know. All I know is that this must be 46. So from here, I've got to have 46. But can you imagine that it can be 46 units over there? And that same distance could have been over there. Because nothing prevents me from putting it there, so that this will be obtuse and this will be acute. And that's the reason why this sum has two possibilities. That angle could have been an acute angle or it could have been an obtuse angle. And originally the syllabus was so that they would ask this question, and if you didn't have two answers, you lost your 1 mark. But they're giving it away now by saying, find the values, you got to go check it, or just find the obtuse angle. So when you got here and saw, okay, well, it's not obtuse, it's acute, so it has to be the one where I take it to the obtuse angle. Now let's go back to case. Because sin is positive in the first and the second quadrants. This was only the first quadrant. So if I did a little KZ summing, it would have also have been, in the second quadrant, it would have been theta is equal to 180 minus. If it was third quadrant, 180 plus, fourth quadrant, 360 minus. But does third quadrant and fourth quadrant make any sense when working the angles of a triangle? No, because I can only have either acute angles or one obtuse one in a triangle. There cannot be an angle of 200 degrees inside a triangle. So if you're looking at a little case, then it's no ways that I'm going to be in the third and fourth quadrant. Although the case parts, when you do general solutions, do have that. Are you with me? Focusing on both of those. So when you get to sin being positive, you have the possibility. But if this was not the case, that the smaller one of the two sides was opposite to the angle, then it was just an acute angle. That's it. Because it was the shorter one, there was two possibilities. So your answer was either that or 102, am I right? Because of this possibility, and please sketch this for yourself just so that you have it and see it, but you're not going to do it again, just to see how can it possibly be. There could have been two possible triangles. This is definitely 70, this is definitely 40, this is definitely 46, but it can sit on different ways. So either I could have a big triangle with an acute angle here and a long side here, or I could have a smaller triangle with an obtuse angle here and a shorter side over there. and it would still have the basic 70, 40, and 46 measurements that was originally given to me. That's why we call it the ambiguous case. But after today, if you never ever hear about that again, and you do get tested on it, the most you'll lose was 1 mark because of not seeing that it's the ambiguous case. But I'm telling you again, they give you the hint by saying, find the values. They're actually saying, do you see what we're giving you the hint? There's going to be 2 possible values, so that you don't always stress about this, okay? Right. So, again, do I have pairs? If we had one sum that didn't have a pair, you just had to do the sum of the angles of the triangle. Everything's fine. I've got a pair, and I've got a half a pair. So then I can always work out, of the 4 things, there can be 1 thing missing. Then I can solve it with an equation. So again, with the sin rule, doesn't matter which one is at the top, sides or angles. I'm looking for the angle, so I'm going to have sin theta at the top over 10. And the other side, angle that I have is 108 over 20. Is this ambiguous?
Yes. Yes.
Why?
Because
The angle is opposite the
shortest side.
longer side. There's 2 sides and an angle, but the angle is opposite the longer side. There's no way that you can do something else than what's here. Okay, so it's not ambiguous. And they never even said anything as well in a test. They would have just said find theta. Find the values. Ooh, not okay, that would have given it away. So to answer the question, we would bring sin theta equal to
0.475.
475, is that right?
Yes.
Don't round off, dot, dot, dot. So that theta, and again, should I do the little KZ? Which quadrants are there?
No.
Think about it, guys. When you do something, there should be a reason. If this was a normal K's sum, it's type 1. Sin is positive in the
First
and second quadrants. But practically in the sum, is it possible that this can be an obtuse angle? Why not?
Because you kind of
Because you already have 100 and something. How can this also be obtuse? Are you with me?
Yes, ma'am.
The thinking is right, but then I say, oh, okay, well, it can't be anyway. So you just do your shift sin, and your answer is?
28.39.
28.35, and that's what? 9. Okay, so now, if this is my next example, we're getting to the cos-rule. Let me get technical. I like it when you write the stuff correctly mathematically. You shouldn't be writing sin rule with a capital letter S and cos-rule with a capital letter C. It's just, you don't do that.
Yes, ma'am.
And I'm not going to deduct log from you, but let's do it right. The cos-rule's coming in. Because if I ask you to go find x here, your first line of defense would have been grade 10, because there's no 90. Grade 11, sin rule, sin rule, sin rule. Why not? You don't have a pair. You have this side, but not the angle. The side, not the angle, not the side. So I do not have the sin rule as an option. So therefore we need something else. Now what the cos rule is, when you have any triangle, they always use ABC, because that's the way that it gets written on your information sheet in grade 12. The cos rule says the following. Again with the A's and the B's and the C's. Now look at this. It's fantastic that Dan is so clever. Nobody's clever, you just have to study. And you know it. Now it looks much worse and more complicated than the sin rule, doesn't it?
Yes, ma'am.
Now you already know what the sin rule is about. It's about pairs. The angle and the side, the angle and the side. So let me explain to you what's going on over here. So I'm trying to find a what? A side. Excellent. Are you with me? Because you know the little numbers. So this would be small a, right? That I'm trying to find. What do I need to find it? You need small b, which is where?
By AC.
Are you with me? By AC. And small c.
By AC.
Are you with me? That's what I need. And again I need them. And then I need
Angle A.
angle A. So what do I need? two sides,
And then
which angle?
A.
The included angle. That's very important. So you need two sides and the included
Angle.
angle. Then you'll be able to work out the third side. So if I have two sides and the included angle, I'm going to use those two sides and included angle to find the third side. So let's have a look at this question. Is that exactly what I was doing over there?
Yes.
Because there's another alternative we're going to do just after this one. So we have please be careful. B squared plus C squared minus 2. The 2 is part of the formula. BC cos. Please be careful that you don't miss one of those C's there. The C and the cos. Are you with me?
Yes, ma'am.
Alright. So now what it means is if I'm looking for a side, whether the side is, and it isn't even side A, do you see it? This is actually called side C. But I always want to focus and brainwash you so that you know what you're doing. If I'm looking for a side, I need the other two sides and the included angle. This is the way I want you to know it. Whether it's X, Y, Z, or it doesn't matter. If you want a side, you need the other two sides and the angle in between them. So let's substitute. So I'm looking for X, right?
Yes, ma'am.
Or if you wanted to write AB, that's also fine. But you're looking for X. So X squared would be equal to which side?
13.
13 first and then 10, 10 first, then 13? Doesn't matter. The two sides and the included angle. So whether you write 10 square, 13 square, or the other way around, it doesn't matter. And then the same thing over there. And you can even swap them, it doesn't really matter. And then cos 50, the angle in between them, so that you recognize what's going on here, that those are two sides and the included angle. Very important. These are two sides and the included angle. That's what it's all about. Whether it's PQR or XYZ, doesn't matter. How would you be able to find that angle off that side now? Just take your calculator. Are you with me? Give me an answer, please.
101,87522.
Which you don't round off because you're not finished. What did we just get here?
The square.
The square. Why square? Because I told you so. Remember, next week I'm going to show you where these things come from. And it's actually from doing the distance formula that this comes from. But to find the side, you first have to find the side square, and then you'll get the answer by just square rooting. So next step. Algebraically will mean that you have to square root. So what do you do when you square root? Plus minus. Really?
Yes.
Because what you
Not here.
distance.
Oh, because of this.
Just practically. Yes, you always say plus minus. But practically, this is a side of a triangle. It can't be negative. You with me?
Yes, ma'am.
But I want you to always think the complete picture for maths. So when you do the square root of that, what do you get?
10,000.
0, 9. Now you round off. And just for interest's sake, I'm saying x is bigger than 0. You don't have to say that. I'm just saying, I know I should have thought about the negative, but it's got to be positive because it's the length of a side. Otherwise, it would have been either plus or minus if it was a different situation. But this is the length of the side of a triangle. Okay. Last scenario. First thing, sin rule. Always. We try the sin rule because it's much nicer, simpler than the cos rule. Why not sin rule?
We don't have
I
pins.
don't have pins. I have all the sides but no angle. So that means no sin rule. So it's got to be the cos rule. So I'm not teaching you a new rule, although some people do like to take that and say you've got to learn this from your head as well. I don't do that. Stick to that. But now I'm looking for an angle. So how can I still use this? I can if I have. Okay, so if this is the question, then I have to have the B and the C
And the A.
and the A. And that's exactly what we do have. And we can always work with equations or with formulas where one of them is unknown. It doesn't have to be the A, it can also be that angle over there. But now importantly, it can't be any of the angles and any of the sides on any of the places. I'm saying we're going to write, and it's not even an ABC triangle. Is that okay?
Yes, ma'am.
Because I've taught you, You have to know what this means. Side, these two sides are included, angle. But now if I give you all of the sides, I'm going to find the angle. But doesn't matter, like over here, we didn't worry about which one was B and which one was C. But doesn't matter which one is A.
Yes.
Why?
Because
It
that
has
is
to
the
correlate with that angle, because that means something, the small A and the big A. They've got to be opposite each other. They've got to be in a plane. So if my angle is theta, that is theta, then this has got to be excellent. No choice. This has got to be in a plane. The A and the A, the theta and the Y if you then want. But the rest of it, okay, now don't forget your square like I just did. The rest of it is the other two sides, which I can put where?
anyway.
Whether it's 7 squared plus 8 squared or 8 squared plus 7 squared, doesn't matter. Oopsie. So you could have swapped them around, it doesn't matter. And what do you need to go find?
Theta.
Theta. How will I do that? Because it's a little bit more tricky than the other one. The other one, you had everything on that side, type it in your calculator, boom, you finished. Got to be careful over here, because the common error that kids make is they want to say square and minus and times, and then that's the answer. Can't do that. Because there's a order of operations. This multiplication must be done first and then added. So if I get rid of it, I've got to first get rid of the adding, do the timing and divide then by it. So the problem that kids have is they do the operations in the wrong order. So let's do it together. So we have 12 square minus 7 square minus 8 square. Do you agree?
Yes.
Give me an answer.
That's one.
You know what you're doing now. So it's 12 square minus 7 square minus 8 square is 31. This answer I can go and do minus 2 times 7 times 8 gives me?
112. Negative 112.
Now that step, I'm not really looking for that step. I'm just trying to show you that you could make a mistake. So if you go and do it on your own, see if you get the correct answer. What would be the next step?
Divide by negative 112.
Can I not say cos theta and make it positive and make it, oh, you can do lots of stuff. Really? I'm not giving you marks for this. I want cos theta. You can get it on the right hand, get it on the left hand, divide the whole thing. You're going to get to cos theta is negative
0.276.
Okay. Now he's already done it into decimals, but if you do that on a calculator, it's going to sit like this. Just leave it that way, because you're not supposed to round off. So rather leave it in fraction form. If you want to write it in decimals, it's fine, don't round off. Then I need to go and get to your angle. What's my problem, or not my problem, or something strange?
You can't have a negative angle.
It's negative. What does that mean? When is cos negative? Case. When is cos negative?
First and fourth.
Second and third.
So first and fourth it's positive. So second and third it's negative. So you should be getting your reference angle first by not putting in the negative. And that gives me shift cos of 31 over 112.
73.90.
Which isn't the answer because it can't be negative in the first quadrant. But second and third. But am I going to do third?
No.
Why not? Third quadrant is angles larger than 180. That doesn't fit with solving triangles. That's correct mathematical reasons, but not in a triangle. So I'll only have in the second quadrant my angle, which is 180. And I didn't have to think hard on it. They gave it away with that negative. If this had been positive, you would have had an acute angle. Because positive is first and fourth, and you don't do fourth because you're in a triangle. Negative is second and third, but you don't do third because you're in a triangle. So it actually gives it away. It's not ambiguous or strange things. You just get to your answer, which is? Okay, now once I have that, can I solve the rest of the triangle? How? Are you allowed to use the cos-rule again? Yes, but please don't.
Sine rule.
Once you have the sine rule, it's much easier, much less stress. than the cos-rule. So you can have the pair and then find either x with its pair or z with its pair. Which one? It doesn't matter. Once you've got one, you get the other one with sum of the angles of a triangle. And that's it. So your homework sums, please, are those two questions for tomorrow.